Hello, everybody, and welcome to Dot to Dot. Today I'm going to talk about 1347. In the past Oak Island episode 2, they discovered in Royston Cave a carved out date. They say it's a date. We're going to look into that. Let me take you to a little presentation that I've done. And we'll do view slideshow. So here is the brick, you could say, in Royston Cave that was brought to the attention of Marty and his son. And it shows a number 1347. Now, this is being related to the Rochefoucauld map, or people call it the Zena-Halpern map. And it is not written as a numeral, but it's written in longhand and in French, the number 1347. So I'm going to give you a little information on this. And let's see. Here's one of the earliest manuscripts that I could find on the internet that actually show the glyphs, the modern day glyphs that we use. 1, 2, 3, 4, 5, 6, 7. Now you notice the 5s, there's 2 numerals in there that I don't understand what that is, but you can see that the glyphs, or the symbols for the numbers that are being used, are pretty much like ours. Now in my research, I find that these symbols or glyphs that were used to denote the Arabic, it's actually Hindu-Arabic numeral system, which was developed in 1202, or at least brought to the attention in Europe in 1202 by Fibonacci. And in this numeral system, it's basically a numeral system where what they call a place-holding numeral system. In other words, as we know it, there's a place for the thousands, there's a place for the hundreds, there's a place for the tens and ones, and so on. And this is the numeral system that was in Europe about 1202. Now, in the 1200s, really, I found that only around 7% of the writers in that time that were writing books on mathematics or whatever, literature, were using these numbers. And in the 1300s, it rose to about 17%. And then in the 1400s, it rose to close to 40%. However, as you can see at the bottom of this document was 1459. And he says at this time, knowledge of numerals was still widely seen as esoteric. So in other words, you basically had to be within a group of people to learn these. And the reason is because the way it was taught was through books. So the printing press was not yet invented. And so therefore, learning these was a little bit difficult. And it really wasn't until the 1500s that it really took off and became a standard for the numeral system. So the Rochefoucauld map, this is what we call it. And really, it's not really a map. It's really, to me, a puzzle. And, we have, of course, the writing up here to Francois Rochefoucauld. Now, it's said before that this was the Francois Rochefoucauld in the 1600s. But you know what? There's a lot of Francois Rochefocaulds. But anyway, I digress. The way that Olivier, who discovered really the key to unlocking this map, was through grammatical errors. So if you can identify the grammatical errors, such in set and petite, and the la in Rochefoucauld is over here where it could have been put right here. And the other one is also the un in the date, 1347, which is 1347. So this is where they get the date 1347. And if we look at how we pronounce and write years, and see, when I first saw this, I thought too it was a date. And I think it's meant to be seen as a date. But if you recognize how it's written in a way that is not a date. And I'm going to show you. In the correct way to pronounce and write dates is there is no un. Because un, even though it is the number one, it's also an article, the article a. So when you write a date, you don't put un because this mille stands for 1,000. So you just write 1,102 or 12. I guess they'll say it's 12. Here's 1444, mille quarante cent quarante. So this is, you do not have an un in the front of this because it is equivalent to 1,000. Okay. So if you put an un in front of it, you're basically saying 1,000. And that is not grammatically correct. What is grammatically correct is when you put an un in front of a weight or a measure or a quantity. And this is what we believe is being said on the Rochefoucauld map. It is a distance, but it's being more than just a distance. It is like a unit of measure, or what we like to call it is a scale. It's a scale. The 1347 in itself is a distance, a scale. Like one of the things that Olivier at Oak Island Research, he was saying that it says un mille, so it meant a mile. And that's the way he was looking at it. But when you look at the context of the document and where that leads, it doesn't really lead to anything. And a mile is really not a unit of measure that would be used in French. French use kilometers. So, and even when we're talking about nautical terms, we're talking about leagues and different kind of measurements that are actually way more than a mile. So the mile doesn't really fit. The milli, the 1,000 does. But this is the context in which a distance or a measure is being used. And they all begin with un or una if it's feminine. So here's another place. This is what we call the Marie note. This is the note that's at the bottom of the Rochefoucauld map. And if you notice, and Olivier from Oak Island Research discovered this also, he noticed that this date right here, which is being set as a date, 1978, begins with an un, and that's grammatically incorrect. It should just be mille. No, it should just start with mille, not an un in front of it. Some of the other things I'll just pass by. Some of the things in the Marie note that may come up later is in my future videos is this right here, this V over the E. This is a clue. This E that is associated with the 80, This is a heading, actually. And this is actually very much linked to the Rochefoucauld map, this clue right here. And the 7 in the January most likely is a reference to the 7 of 1 pieces, which the Rochefoucauld, which the La Formula was. It was 1 of 7 pieces. So anyway, that's the another reference to un mille. And the other reference is in La Formula itself. And La Formula actually states it as a distance because they have a unit of measure here, which is pied. And here we have un mille. So it's 1,065 feet. And basically what this says is enter the corridor at 1,065 feet. So this is a distance. So when we look at pied here. I found out, and this actually came from a viewer who wrote in the comment section. This was like over a year ago, and he turned me on to this information here about the units of measure for pied. And actually from 1790, Charlemagne is the one that instituted the toise, which had 6 pieds, and the pieds were 326.6 millimeters per pied. So this is the unit of measure that I'm using. And actually what I find really works well is that if this is rounded off to 327 millimeters. So what happened here? There's supposed to be a picture. All right, let me escape here. There we go. I guess that's not going to come up. So anyway, this is the meaning that I believe the 1347 is. And it is the distance from cone E to the north anchor. And when you use the 326.6 or 327 pied and multiply it by 1347 and then divide it by our foot, millimeters by foot, which is actually 304.8, but I use 305, we get 1,444 feet, 0.1. The distance from cone E in Nolan's Cross to the headstone is 722 feet. When you double that, you get 1,444 feet. This is what I believe is the meaning of 1347. I put this down here just so you know that the difference, if you're going to not use rounded off numbers, is 9.6 inches. It's not very much. So this is what I believe the 1347 is. Now, it doesn't mean that the 1347 wasn't a date also, because I always wondered, why did they pick that number? Because did they pick that number because of this, because of Nolan's Cross? Probably not. They picked the number and designed it according to this number. And, 1347 is also the year that the Black Plague started. And the Black Plague is definitely a year we remember, or at least the French would have remembered 1347. So before I go any further, I'm going to bring up the reason why 1347 is so important. And it's right here. And what it is associated with is the landing. Now, I've done a previous video on this before, and it's called The Landing. And the landing is basically what it's doing is taking all the errors, grammatical errors, and little symbols that are on the Rochefoucauld map and putting it together as a geometry that will basically rebuild Nolan's Cross. And this is done through the landing and understanding the pictures and the errors in the writing, like the petite and the set. These are both errors, and the I squeezed in here actually becomes a vector. When you line it up and you bring it down to this line right here, which is the stop line. Notice also that this E is being boxed in by the completed puzzle. This angle right here is 80, heading of 80 degrees true north. This is the E that I spoke of in the Marie note. This is what is designated here as 80 degrees, true heading of 80 degrees. It's also the reason why this E up here is so accentuated. It's like they accentuated this E up here for a reason. The other clues is, of course, the little V, which is right here, which comes off of the la. It's also shown with this little symbol, the little V that wanders. And it wanders and it sets up to hit the middle of the trident or the quadrant. So this is also the way that you find 1347 as a distance, as a scale. Once this is completed, and it's completed with finding cone D and taking this measurement from this little foot measurement here, which is associated to this line right here, and you put it perpendicular to this bisector of these angles. See, what we're trying to do is we're trying to recreate this quadrant here, which will become the top of this triangle right here. This right here is associated with this. And this right here is where you start from the top of the apex of this triangle, which its base is on this parallel line, which is basically the crossbar, Nolan's cross. And it comes down to the stop line, which is right here. So this distance right here is the 1347. This is how we get the scale distance out of what I call the landing, or what the map calls the landing. This is the landing because it doesn't matter what this dimension is. It can be any size. But if you measure from here to here and put it the same distance from here to here and then double it to the top of the triangle, you put it down to this point, you're making this line a certain distance, and they're calling out this distance as 1347. I know it's sort of confusing. It's something that it's really remarkable once you understand it, because it basically is giving you a geometric, uh, basically a geometric point on the island with a scale, and also it gives you a reference to the way it's set up. And the way it's set up is this this line that comes from the top of the triangle to the point goes 1347. Well, it ends up here, and that is taken off here. This distance comes off of here. And that's what happens. When you extend that line, it goes out to that point that's shown on the map. And what's interesting about this line is that it's 3 times 1347 from this point right here, which we call the 429 extension. And when that is set up, the Ver line, which we call this line right here, that goes through the middle of the quadrant, which becomes L'Hamp, ends up at Round Island. And there's 3 boulders on there in the shape of a V that give the east-west line. And that's what you realize, that line is east-west, and there's your second orientation line. So now you have 2 points of orientation. You have a scale, so you can take these lines that you've created from the quadrant, and they end up being Nolan's Cross. It's a pretty remarkable thing, and the orientation of Nolan's Cross, okay, it began really at cone D and cone C, because if you took it 90 degrees, the position of cone A or cone D and cone C, that position is basically giving the orientation of Nolan's Cross, this axis here. Oh, and how did we know that it's cone C? Because this is cone C that this is pointing to. And this is the set line that goes down right here. Another thing too is the orientation of the quadrant goes to a 45-degree angle, and that 45-degree angle is where L'Hamp is. L'Hamp is right here, and the L'Hamp comes from La Formula, and L'Hamp means the shaft of a spear or a lance, and that's what this is. This arrow denotes a spear or a lance. And another thing, this is funny, is Marty on Oak Island, the thing, he was saying that this fish may be mesoline, have something to do with mesoline. Well, this comes from the Little Lion of Tomont. You know, the Little Lion of Tomont, the only thing I can think of is because Castle of Tomont was occupied by Richard the Lionhearted, who basically, Richard the Lionhearted was the son of King Henry II. And you know what King Henry II, his title was King Henry the Lion. So if King Henry the Lion, the father of Richard the Lionhearted, that would make Richard the Lionhearted a lion cub. Just an idea. But one of the things that I found out through Wikipedia is Richard the Lionhearted was also associated with the Mesolene tale, that he was a descendant of the ancestress of Mesolene. So, and I don't want to be politically incorrect or offend anybody or anything like that. But if Mesolene was a female fish, what was this? What gender is this fish? And it could be a clue. That's just funny, but I don't know. But one of the other things about this is Le Sud Indien works well. So one of the other things that can be also associated with this and that arrow is Indians, they fish, and one of their main ways of fishing is using a spear. So this could be in reference to this, basically telling you, that this is part of the solution. This sets up the 45-degree angle, which is in La Formula. Also, it brings attention to the Sud, and that is right here. And if you notice, it has the D comes to the headstone, and the S comes to the cone A, which is cone A that's the reason why, or that's the place where the 45-degree angle starts. That goes to the oak entrance and the 522. This is where the 522 distance from La Hampe to the 522, that's in La Formula. And then it ends up at the Triangle of Peter. And that's also another clue, pictorial clue that's in here. This may be in reference to that arrow and the dot being at a 45-degree angle, which would be the Triangle of Peter, which is right. It's in the title of Triangle of Peter. So 1347, what else does 1347 do? Well, let's do this. Let's take away this, and we'll take away this, and we'll take away all the clues, and we'll take away that. Oh, no, let's leave the locations on. Take away that. So here we have the locations that are on the Rochefoucauld map. Here's the landmark map right here. And so these are all the locations that they're trying to find. And if you take the 1444, the 1347 distance, and you, which is the distance from the North Anchor to Cone E. If you take the distance from the North Anchor, you end up going through Triangle 2. Now, how do we know that's Triangle 2? Well, the Triangle 2, when you find the location of the South Anchor, which you cannot find the South Anchor until the Oak Entrance is discovered, and that's a whole nother story. But if you take the distance 1444 or 1347 from the South Anchor, this is how you locate Triangle 2 on a macro basis. There is actually a microgeometry that connects with Cone E to Triangle 2, and you'll find out that this Triangle 2 is actually due north of the vault position. Because really, why is the vault even mentioned? It's under the earth. Why is it even mentioned on the map? You could say that for the hole under the trap door. This is under the earth. I think the valve may be the surface entrance, but these are the reason why they're on the map. There's only one reason, is because they form a geometry in order to find something. And that something may be the valve. Really, I haven't really discovered for sure that that is true. But I know that they're on this map because there's a geometric association to each one of these locations. So we have 1, 2, 3, and then the last one is the center is cone E. And that gives us one reference to the hole under the trapdoor, but it also goes to the oak entrance. So this is one reference. The other reference to locate the hole under the oak entrance was the 45-degree angle, which I took off. Where is it? The 45 right here. That's the other way you find the oak entrance. That's one of the ways. There's another way that's more local than from cone E and from cone A, which is through the triangle, the stone triangle, which I believe is associated with the whole geometry in this map. And didn't I show you guys? Did I show? Oh yes, I did. The stone triangle is where this big circle that went through the two, the Frog Island and the Round Island, they're equal distance. I'll show that to you. So let's see. Take off the landmark map. This is where the stone triangle is, and they are equal distance from the stone triangle. These landmarks that are right here, and also on Frog Island. This is where you end up on Frog Island. So this is the importance. At least this is what I've come up with through the help of Olivier, and it was definitely him that opened up all the secrets to decoding the Rochefoucauld map and where the 1347 is. Now, 1347 is definitely a year we remember. And if you remember, if you've read either Zena Halpern's book or the Scrolls of Antiara, the Cremona documents start with a document that was supposedly written during Templar times called A Year We Remember. And maybe 1347 was basically picked for that reason. So it could be a date, but I guarantee you in this instance on the Rochefoucauld map, it's a distance. And that's the way it is. Thanks for watching. Like and subscribe if you haven't already, and I'll talk to you later.